Alright, let's talk about JavaScript promises. Why they exist, what problem is it that they solve, and how to use them. Well, to talk about why they exist at all, we need to understand a little bit about JavaScript's background. Mostly that JavaScript is single-threaded. Yes, we have worker threads, but they're completely their own separate process and can only communicate through message passing. It's really hard to do the shared memory things. And there's a good reason to be single-threaded if you're JavaScript. One of them is, of course, JavaScript was never meant to do heavy-duty stuff that we ask it to today. For instance, Google Slides is heavily JavaScript. It was never meant to do stuff like that. It was meant to supplement an HTML page. So checking user input for correctness before being sent to the server, changing images when you click a button, fancy things like that. It was never meant to be a full-fledged application language. So you would never need more than one thread, but more importantly is when you are modifying the user interface, which is what JavaScript was designed to do, was to modify the DOM, document object model, and those changes get reflected in real time. To modify the user interface from more than one thread is an incredibly hard problem. You can't really guarantee that there won't be deadlocks and you get weird behavior, and it's a mess. So an easy way to fix that is to only have one thread of execution that can modify the user interface. So JavaScript does this. I know JavaFX as well. Only the main thread of execution can modify what the user's looking at. And .NET Framework is the same as well, as are probably other ones that I don't know about. So what do we mean by this single-threadedness? Let's take a look at a basic HTML page. We have a whole bunch of boilerplate, and the only thing in the page is this single button that has 3 events attached to it with some code attached to those events. So we have an on-click listener, on-mouse over, and on-mouse out. So when it gets clicked, we call this function, which just alerts ouch. When the mouse mouses over this button, we pass in this element, and we change the font weight to bold, and then when you mouse out, we change it back to nothing. So let's take a look at this. We can open it with Live Server. You can open it from the file directory directly. All right, it's just a button, not much to see here. But when I mouse over it, we see the button become bold, and when I click it, we get the alert, ouch. Now, let's test this single-threaded theory by creating a really tight loop. So let's say let in for now equal date.now. And let's say while date.now minus in is less than 2 seconds, do nothing, just sit there. So this code is going to get executed as soon as the page loads. So remember, the browser, in addition to loading elements as it comes across them, it will execute script as it comes across them. So let's save, and let's open that web page back up. And you see it's loading for, I would guess, 2 seconds. And while this code is executing, I can't interact with my web page at all. So number one, we need to be careful about the JavaScript code that we include. We don't want to do a lot right at startup to make the page load longer, and we have to be careful about where we put our JavaScript and how blocking it is. You don't want it to ever block more than, 10 milliseconds, because the user will notice it and be frustrated. They'll try to interact with your page and won't be able to. Now, a very common thing that you would want to do in JavaScript is go out on the web and receive data from somewhere. So here's a page I made for KJHK a while back, the student radio station, and it visits another place on kjhk.org, but it's through HTTP, and it gets the now playing information, and then it takes that info and sends it off to another web address where a program is running that takes that information and then sends that off to Spotify, asking for the URL for the album art. And I have an image sort of describing what's going on here. So the now playing page, no, I don't want it that big. Every 10 seconds or so, see, it changes live, and if we don't find the album art for whatever album is listed, we just show this nice little logo. We first query to kjhk.org for what song is currently being played, and we do that every 10 seconds or so. It's easy enough to do a set timeout that calls itself. And if that song is different than the one that we're currently showing, then we need to get the new album URL. So we first get the song information. Using that information, we send our request to our custom Spotify interface, which then takes that information, does some work, attaches some credentials to it, say, hey, who's asking for this information, because Spotify doesn't just give it to anyone, and sends that request off, gets the response back, and then forwards that on back to the now playing page. The important part is we have two web ventures where we go out and get information on the web, and this one depends on this one happening first. Okay, so let's look at how we might code something like this. So this will be pseudocode, but say in some sort of function that repeats. So maybe in here we do some sort of set timeout, blah, 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 whatever. But the first thing we're going to have to do is get the song data. So song data equal, let's pretend I have a function called get song data somewhere that goes out on the web and gets that information. And then, of course, I'm going to do something like set UI, or maybe set song data UI. And then using that song information, I need to let album URL equal get album URL. And it needs that song data to do so. Well, this is effective in the sense that I am doing this first, and then I am doing this, but there's a lot of issues here. The first one is, well, what if something goes wrong? I'm not handling any of my errors, of course. Like, what if the connection times out? Or maybe that website is currently down. Maybe this website is currently down. I'm not handling any of that. The other thing is, this code would be blocking, what we call synchronous, as in this is executed in its entirety, then this is executed, then this is executed, which seems pretty normal. Why give that a special name? Of course, that's the way code gets run. Is this synchronous? This runs. When it's finished, the next thing runs, and when that's finished, the next thing runs, and so on and so forth. Well, this isn't good also because most of my time in a web request, where did my picture go? Most of my time in this web request is just waiting for a response. I can send it off and then just wait for something to happen. And the way this is written is we're going to have to wait that whole time and do nothing, which we've learned will block the user interface. The user will not be able to interact with our page. And here we see that the user interface is very responsive. Everything seems fine. So somehow we're not blocking, which is good. And then down here we're going to be blocking once again. So what would be really nice is if we had some mechanism very similar to what we see up here on these, where I have some code that wants to get run on the event that we receive the response. I want to get things started, and then once I get a response, I have some code that I would like to attach to that event. But I don't need to just sit here and wait for it the whole time. That's not good. Okay? So my intuition is that this functionality exists because something is helping us do all of these event listening and function calling, right? I don't have to do any other work other than saying this right? There's nothing else down here. And somehow, magically, whenever these events happen, this code gets executed. So let's take a look at the JavaScript Runtime and all of its secrets. Okay, so this is a site called Latent Flip, written by Philip Roberts, who is a web developer. It was written a few years ago, so a lot of the newer features of JavaScript don't work in this simulation. But it works really nice for just explaining things. So let's delay it quite a bit, actually. And the traditional execution model of a call stack is all that we're going to see in this example, right? We don't do anything of, we're not setting any event listeners, we're not doing any set timeouts, so we don't need all this other extra stuff. There's no secrets in here. The secrets are when we do stuff like setting event listeners. Okay, so in general though, your code runs here. This is your execution call stack. And if you were to execute, I'm saying execute with quote fingers, execute something like a set timeout or attaching an event listener to something, that is given to your friend over here, just called the web APIs, this magical place that handles all of your events, and then whenever that event happens, in this example, whenever this button gets clicked, it triggers this code to get ran. One of those, oh, whoops. And where'd it go? Here we go. But it doesn't just start running on the call stack, right? We don't have interrupts in JavaScript. So we're single-threaded. How do we get this event to run if we don't interrupt what's going on the call stack? So what we do is we have this other entity called the callback queue. And whenever an event gets triggered, the code attached to that event, in this example, the myClick function, gets put into the callback queue. And then we wait. We wait until whatever currently running JavaScript completely finishes. Right? So I'm not doing anything in this code here. I'm not console.logging anything. All I'm doing is declaring a bunch of functions. But maybe I had a bunch of code that runs here. That would finish running. And then once it's completely done, this event loop is constantly monitoring, is there anything on the call stack? Is there anything in the callback queue? And once the call stack is empty, it will take the first thing in the queue, put it on the stack to be executed. And then if there's something else, it will again wait for this to completely finish and then put this next thing in the call stack. So what we're going to see in this example is just a basic execution model. This is going to get put onto the call stack and executed, popped off, then this call will, and some function declarations, and then we call the function A. A calls the function B, and once it's finished, we'll say finish A. B calls C, and then prints out finish B, and then C just says it is finished. And then we'll pop off the stack, B will print, pop off the stack, and then A will print and pop off the stack. So let's see it. Okay, it's a really nice visualization in general if you don't know much about call stacks and the execution of programs. But now let's look at the more interesting example. Why does it keep doing that? It's annoying. Get out of here. So, we're not registering an event like this. We're using jQuery here, which is fine. It's the same semantics, different syntax. And this will register an event for whenever a button gets clicked, do this function. Okay. And that function contains a set timeout, which will again just be given to the web API, told to wait 2 seconds and then give me this code back to run. So this is an interesting point. Whenever you call set timeout anywhere, you give it a function and the amount of time to wait. This is not a guarantee. You are not guaranteed when this set timeout first gets executed that this code will run in exactly 2 seconds. I think maybe you see why that is. Whenever we encounter a set timeout, that is given to the web API, and the web API will wait 2 seconds. In this example, 2 seconds. And then we'll trigger the event of this timeout happening, and then this code, whatever code is given here, will get passed into the callback queue to be run. Well, it will be run in more than 2 seconds if there's something currently happening on the call stack. So this is a minimum time to execution, not any sort of guarantee whatsoever. Okay, so we're going to register this callback event with the web API, and then the web APIs section. There's lots of different APIs. We'll see a couple of them. One, of course, is this event registering. So the DOM is a nice API to have. And then it's going to print hi. And then we're going to do a set timeout of 5 seconds that tells me to click the button. And then there's another console.log of welcome to loop. So the order of this code is going to be what? This is going to execute, as in this is going to get registered, but there's nothing that's going to get printed. This is going to be the first thing that's printed. This isn't going to happen yet. So this is going to print. We're going to register this set timeout. Then this is going to happen. And then if I don't click the button in 5 seconds, this will happen. And then as I click the button, we will execute this, which triggers this to happen in at least 2 seconds from when it gets clicked. Okay, so let's see it in action. Let's set the delay to be a reasonable amount. And let's run it. Okay, that event is registered. We log hello. This set timeout gets passed to the web API to wait 5 seconds. We continue executing. 5 seconds pass. That function gets passed in, and timeout says to print, and then it prints. And if you're not familiar with the term web API, API is just application programming interface, and it's our way of interacting with some other features that we didn't have to write. Right? That's one way to think of it. So this set timeout, the way we interact with this feature is we call the function set timeout. So it appears to be completely JavaScript, right? But it's secretly not executing here. That set timeout gets given to the web API to handle, which will wait the amount and then pass that code to be run after that amount of time down here. So let's click the button a few times. Let's start with once. So this can be pretty buggy. So let's go through this one more time. Okay, console.log gets printed. We register the set timeout. Timer gets started. We print this and run that code. Timeout calls console.log. It finishes, and then timeout finishes. Now, if I click, the event attached to this listener, which is this code here, gets run. And let's see that one more time. So as soon as I click, the onClick event runs. So that set timeout executes, which starts a timer for 2 seconds. And then we run timer after that amount of time, which prints you click the button. So this is nice because it is what we call asynchronous, as in this code attached to the button click doesn't now I have to run it again. I can't click there, I guess. The code attached to the button click is asynchronous, as in it returns immediately and will do some work later. And there's some code attached to some event. In this example, this timeout event, and this is the code attached to it. So it returns immediately, and if I click this button a bunch, the web page remains responsive the entire time, and all of these events get queued up. So if I had some mouse over events or some other button events, they would all still register, and each thing gets to run on the queue, or sorry, in the call stack, and the callback queue keeps growing. I shouldn't have clicked so many times when it's set to this slow. You can see each set timeout event being registered, and then that timer gets set to the end of the queue. Okay, so all of these events happen well, whenever this call stack gets empty. So back to this code. We want to be able to do this asynchronously, like these events are asynchronous. So it would be nice if we could send our request and then attach some code to the event of getting a response. That way, we do not block the user interface. We might wait 5 or 6 seconds for a response, and that's totally fine. The web page will be responsive the whole time we're waiting, as opposed to this synchronous way of do not move from this statement until it's completely done, then we will do this, and then we will do this. So the mechanism we have, or the web API for doing this asynchronous thing, is called the XML Http Request. It is not a good name at all. It should have been named HTTP Request, but it is called XML HTTP Request for historical reasons. So we create a new one of these, and this looks like just normal JavaScript, but this special object is our way of interacting with this functionality of the web API. One of the web APIs, I should say. There's other things you can use now, but we're justifying why promises exist, so we're going to explore this a little bit. So we create a new one of these things, and then we attach some code to the event on ready state change. Unfortunately, that's the only event we have. We don't have on data received event, but that information is available to us by checking the ready state. Ready state 4 is we have received information, and that the status is 200, as in everything is good. And then in here is where we would do whatever we need to do to set the song, album, and artist information. And else, actually, I should change this a little bit. This should be, if ready state, oops, didn't mean to change it like that. If ready state is equal to 4, as in this is the final event that I'm interested in. I'm not interested in the other events. Let's just completely ignore them. And if the status is 200 on ready state 4, then do good things. Otherwise, something bad has happened. We didn't properly receive data. The status wasn't 200. Either we timed out, page wasn't found, 404, something bad happened. Okay, and for all other on ready state changes, we just ignore. We don't do anything. So if the status is good, we go ahead and set whatever elements we need to according to what this response text is. Otherwise, we need to handle failure in some way. In this example, we just say get the element called demo and set its contents to could not connect. So this is exactly what we were looking for. This is what we want to do to set the song data for that web page. For where to go? Nope. Here we go. To set the song data. But remember that we have another web request to make dependent on the song data. So once we have the song data, we need to go get the album. Now, the way we might do this was we need to do all of this over again. Well, I guess I should finish walking through what this does. So we create a new XHTTP request element. We attach code to the event. We say open with a GET request, whatever this URL happens to be. I just put a dumb value in here, kjhk URL. But this would look like http:// whatever, blah, blah, blah. And then you actually send it. So this happens, we register this event, we execute this, sometime later this will get executed on this event. And we need to do all of this over again when we succeed. So right here. But let's call it number 2, 2, 2, 2. Is that all of them? Yeah, okay, that's all of them. Well, you can start to see the problem. When you need to chain together these asynchronous events, this code gets a little bit hard to read. So now my flow of execution depends on indents, right? This gets pretty confusing. Where this happens, I register all of this code on that event, then this happens, then this happens. Then when I get the response, I do, this is confusing. Okay, I do this, then I create a new response, and then I attach code to that listener, and then, okay, and then you open, you know, this would be the Spotify API URL, whatever that is. And then I would also, you know, somehow include the song information. I didn't mean to change this, did I? Wait, no, this one. This is what I want. I would somehow include the song data into that request. In the perfect world, I wouldn't have to modify anything, but of course you have to change what this request looks like a little bit. And it gets pretty messy pretty quickly. Imagine I have a third asynchronous event that I need to chain to this. Then I would nest that. I have to think about it even to do that. Okay, I'd have to nest it here. Okay, so this is very unreadable. And this is also what we would call tightly coupled, where if I need to change one chunk of functionality, right, then I have to go in here and change essentially all of it because it's all written here. So we can write this a little bit better. I'm going to make a function called make HTTP request. And it takes a URL. Oh, dang. And let's take this. Oh, this needs to be HTTP2, right? It's confusing. I'm making my point for me. Yeah, okay, I think that's good now. But this is one instance of that code that, okay, yeah, it's called HTTP2, but who cares? And the URL that it visits is the URL that you pass in. And to encapsulate this in the general case, we can take advantage of the fact that functions are first-class objects in JavaScript. So an additional parameter to this, I'm going to say is on success. I could name it anything I want, but what should I do when I successfully make this request? So we want to set the song, album, and artist info, but that was for our specific example. To generalize this so we can use this anywhere, response text. You pass in a function that you want to be applied to the resultant data. Okay, so you could pass in any function that you want to handle this. So say we have a function. Let me hide all of this real quick. Let's just get that out of our thoughts. I'm just using this as a notepad to write a bunch of code. Function set song data, which takes the song information and then changes the HTML elements as appropriate. So then if I wanted to use this new decoupled version in something like function.main, say for example, or our repeater, whatever, I would say make HTTP request, and the URL is, you know, http://kjhk blah blah blah, whatever it happens to be. Now playing, you know, and then I would pass set song data. I forgot to give this a definition. So song data. And then in here we would set our HTML elements. Oops. You know you're writing a lot of code when you end comments in semicolon. Okay, so now we do this HTTP request, and we can reuse this function for anything we want. And on success, it will call set song data with the information that it received. Now we should also include something like on failure, so that when this function fails, we should handle it nicely. So else, let's get rid of this, and we will call on failure. And maybe we pass in a parameter. You can ignore it or not. It's JavaScript. You can do whatever you want. I pass you a parameter. You don't have to use it. You don't even have to write it in your function definition. Something went wrong. Brownie face. And you could put any other code within your on failure. So now when I call this down here, set song data, and then let's define a function called handle failure, which will do something along the lines of letting the user know that something went wrong. So maybe we console.log this error, so a normal user wouldn't see it, and then we do some DOM manipulation to show no info in the DOM. So maybe we set the song to --, the album to --, the artist to --, you know, whatever you want. Or maybe you set it to yourself whenever there's no information. You can have fun. And okay, so this is a little bit nicer. It's decoupled. Now, how could we chain together our asynchronous calls? Once I get the song info, I need to set the song data, but then also get the album information using that data. So I can go in this initial request, and I'm going to say there's a new function. There's a new function I want you to do when you successfully get the song data, and I'm just going to write it in here. I'm going to write it in line. So whenever you get the song data, I want you to set song data. I should name this a little better. Set song data HTML elements to be a little more clear. It's a little misleading. I lost my spot. Okay, song data. We need to set those HTML elements, but then we also need to make a new HTTP request with that song data. So the URL is going to be, I don't know, the Spotify API that tells us the album art URL. You know, we're using our song data. And the code that I need attached to that is, well, we need to write a function that is set album art HTML element. I should camel case this. Oops. Set album, there we go. Set album art HTML. And on failure, let's just do the same. Or let's do set stock image. So we have some image that we set whenever we don't find the album, which I think I can't show you now, but it'll just show a KGHK logo if no album shows up. Okay, I'm not going to take the time to actually make these, but I'm just showing you how. That's not how you spell album. Album. Okay, so I think this works now. Set stock image on failure. Okay, great. And again, this works. This isn't terrible, but it starts to get a bit confusing when you're talking about what order things happen in. imagine I need to now do something with the album URL, just like we had to do another asynchronous request with the song data. What if we get the album URL and then we need to go visit something else after that? Well, we'd have to replace this with, album URL result with a new function that, of course, sets the album with, man, that word just gives me lots of trouble, doesn't it? Album. And then do our make HTTP request with that data. Okay? So, again, this works, but the control flow gets really confusing the more in-depth you go. Everything's pretty okay for 1. If you need to nest 2, it's not terrible, but it gets pretty confusing. 3 and more gets really confusing in the order that things happen in. So this is called callback hell, because these functions are called callbacks, as in what should I do when I'm done, and it calls back to these when execution is finished. At least, generally speaking, all this work here is done. What should I do now? Well, either do this function or do this function once you have that information. So to avoid callback hell, a lot of library programmers in JavaScript made their own version of JavaScript Promises, which was great. People loved it. The issue with that was each library used their own version of JavaScript Promises because there was no standard. There was no standard idea of this JavaScript promise. And by the way, JavaScript promises were initially called deferred. They were called deferreds. Maybe that's why they changed the name to promise when they actually released the standard, because deferreds is hard to say. And promises is easy to pluralize. I don't know why they changed the name, but they used to be called deferred, which kind of makes more sense to me than saying a promise. But if you think of it as, so I'll get this promise started, I'll initiate it, and then I promise to do the rest of this code later, right? Whatever this on success is, I promise to do that after these events happen, or this on failure. But I'm not going to do it right now. So that's where the name promise comes from. So everyone's using their own version of promises, and they do not interplay well. Maybe some libraries can interplay with other libraries' promises if they use the same promise library, but not everyone. So you couldn't do asynchronous things from one library and then do asynchronous things that need to depend on those things in a different library. So the need for a standard JavaScript promise arose. And let's take a look at how we could do all of this with a JavaScript promise. So let me take this code. I'm just going to copy and paste it, and we're going to take it with us. Let's get out of here and let's enter a file called main.js that I made. There's nothing in here yet. I'm going to import it into here so we can actually see it run. And let's make a function called HTTP Request Promise. And it takes a URL, and that's it. Notice it's not going to take, as in this example, what I should do on success and on failure. We shall see why. So I want to return a new promise. So this is how we use promises in JavaScript. They are implemented as an object. So you can just create a new one. And the the parameter that you pass to this constructor of promise is a function, okay? It's expecting a function as a parameter. And it gets kind of meta. So the parameters to this function that you pass in to promise are also functions, okay? Because we are encapsulating this idea of what should I do on success and what should I do on failure, okay? So I'm not going to write it in here because that can be a little confusing. Let's just define a function right above it called myF. And it's a function that takes two parameters that are themselves functions. Okay, I think this is where a lot of students get confused. So you pass in a function to the promise constructor, and that function takes two parameters that are going to be functions. And this is how we would use it. So if we wanted to do an HTTP request, just like we encapsulated that by using functions as parameters here, here I have called my onSuccess function resolve and my onFailure function reject. I could have changed the parameter names to onSuccess and onFailure, and that's totally acceptable as long as you have a function that accepts two parameters that are called throughout this function, right? As long as you have a function that takes two parameters and you pass it into promise, everything's fine. But it is very, very common, and it's like the standard, to call the parameters resolve and reject. As in the promise, what should we do when we're resolving the promise? Everything's finished and everything's good. And what should we do when we are rejecting this promise? When something bad happened. Okay? So when things are good, we will resolve, and we're going to resolve with this value. And when we reject, we're going to reject with something went wrong. And we could be more descriptive. Maybe we pass in some information from XHTTP to, there's probably some error message we could get, like what was the status. That would be a good thing to include. Was it page not found, server error, things like that. So now we can use this. Okay, so this function called HTTP request promise, maybe I should call it promise request. I'm not sure, because it's not like I'm requesting a promise. I'm doing an HTTP request with a promise. Yeah, I'm going to rename that. I don't like it anymore. Let's call it promise HTTP request. So it defines this function, but if we ignore it, all it does is return a new promise created using this function, which performs this asynchronous work and will either resolve or reject. Okay, so now how would we use this? If we have a main function, we could say let song data promise equal promise HTTP request, and then this is the KJHK URL, whatever that is. Now I have computation that needs to happen after that finishes. So we have, why is that plural? Song data promise. The promise object has a method called then, which makes sense. So do this promise. Then once it resolves, you pass in a function that you want done. In our example, maybe we have a function defined that is set, as we discussed, set song HTML elements. And let's define that up here. And that takes that song info and sets the DOM. Okay, we also could have just written, song info. We could have inlined this function if it's not going to be useful to us anywhere else, and pass that in directly. So it becomes pretty clear that this should happen, as in the body of this happens, and when it is resolved, I want you to do this with what gets resolved. Okay, so to test this, I don't want to do actual HTTP requests. What I'm going to do is I'm going to make a function called fake promise, because any promise that does asynchronous things is about the same. So I'm going to ignore the web stuff for now. And let's just make a function called make promise. And it takes a name. Let's name our promises and That's it for now. So a quick and dirty way to fake asynchronous events, or I guess to simulate, well, an instance of a nice, easy asynchronous event is the set timeout. Okay, so I know I'm going to return a new promise, and the parameter to that promise, remember, is a function that takes two parameters, resolve and reject. And I'm going to resolve 90% of the time and reject 10% of the time, just to simulate random error of a terrible, terrible internet connection that fails 10% of the time. So let's say let random equal math dot random, and let's make a random delay as well to simulate the real world. Delay is math dot random times 1.5 seconds. So maximum of 1.5 seconds delay. And then we will do our asynchronous work. We're going to set timeout, and we're going to wait d seconds. And this is the function I want you to do after d seconds. If r is less than 0.1, so 10% of the time, reject. And let's give it a value. Let's reject with name. Rejected. R was R. Else, 90% of the time, we're going to resolve and say name resolved. We're very happy about it. Oops. And let's say R was R. Right, so this make promise will create a promise that after some random amount of time between 0 and 1500 milliseconds will resolve or reject depending on the value of R. So let's say that the song data promise is make promise, and this is pretend song data request. It's the name of it. And then let's show that the resolved value gets passed as this parameter in the then function. So let's just do a console.log, said in then, and song info is what we have received. Okay, so let's attach this main method to my onClick method to this button, and save it, and bring this back up, and let's bring up the console so we can see what's going on. And let's click this button. Oh, main is not defined. Of course it's not. So let's let it know that it exists. Source equals. Wait, I saw it. There it is. Okay, now let's save and run. Let's see, something is strange here. Oh, I didn't know that you could do that. I don't understand why that executed. All right. Anyway, so I meant to pass this as a parameter to resolve, just like reject. All right, let's save and then look at what's going on. Okay, so I click and then in then, which prints, if you remember the name, resolved or rejected. So pretend song data request. Let's get rid of that period. I don't like that. Oh, now I have to do it again. So in then, pretend song data request resolved, and R was much higher than 0.1. So this is a pretend successful web request. But what happens if I keep clicking? Okay, success. What happens 10% of the time? So we get an error. We get an actual real-life error from JavaScript. Uncaught in promise, pretend song data request rejected. That was our rejected value. It's a very helpful error message. It was much lower than 0.1. But I get an error in JavaScript because it wasn't caught. So you have another function available to you. And what's really cool about promises and calling .then on promises is the .then function returns another promise. So I could call .then to chain another event to happen after the previous one, or I can say catch, and let's say what was the error, and console.log in catch error was error, and we won't do anything more than that, but we handle it. We handle that. And I can keep clicking the button and everything remains responsive because we are doing these calls asynchronously. Somebody fail, come on. Did one fail and I missed it? Oh. Ah, I saw one. Okay. So now we see that the inCatch catches the error case and is passed as a parameter whatever gets rejected, the rejected value, which prints the name, pretend song data request, was rejected, and R was indeed lower than 0.1, a random number. So let's go ahead and continue simulating our next thing, right? So our next, I'm going to insert it between the then and the catch. Right after I get the song data, I'm going to say .then again and say song data and or song info, whatever. I can call my parameters whatever I want. Let's say in second then and print the song data. And let's see what happens. Now when I, uncaught reference error. What have I done? Oops, I see what I've done. Okay, there, how about that? Okay, we failed. Okay, now we get in then, we were resolved. In second then, undefined. So why was the parameter to our second then undefined? It was because this is designed to chain asynchronous events together. So this then gets the result of whatever this then returned. And I didn't return anything. What if I return the value 1? 1, not as a string. Now we get the in then, if the promise succeeds, and it does. The promise is resolved. In second then receives the value returned from the first then. So if I want to encapsulate sort of my actions nicely, song info first, set song data elements in my HTML. Then I would return that song info to the next then. And here I would, well, let's just do that to show that that works. In second then, and then the value received is the whole value passed in from the song info, okay, which is the name of the promise that resolved and why it resolved. Okay, great. So we can get data from here into here. But what I want to do is another asynchronous event, right? I want to make a promise. So let's say let album p for album promise equal make promise, that is the Spotify URL roughly like this plus song data. But how do I if I'm going to then do something like set album URL, wherever that function is, this doesn't seem to help us. I'm still nesting. Isn't that what we were trying to avoid all along? Was this the callback hell that we saw? So when you return a value in a then, it does get sent to the next then, but we have this nice feature we get for free that if I return a promise, I don't get that promise in the next then. I get the value resolved in that promise. Does that make sense? So I will get as v, as a parameter here, what this return to promise resolves with, which will be the name of the promise resolved with an R value. So Spotify URL question mark. I'm just going to ignore, I'm not going to put that in because it's going to get really long. So Spotify URL and then R value. So let's just do a console.log of in third then, and v is v. V sub v. All right, let's see what we get. So we're in the first then, in second then with that data once again, and then in third then, v is the result of this promise. All right, so we can keep chaining sort of top level in our thens for our asynchronous events. So here we returned, none of this was asynchronous, which was totally fine. We can do synchronous work here. You can have synchronous work that depends on asynchronous work, but you can also have asynchronous work that depends on other asynchronous work and chains quite nicely, sort of top level. So you don't have this nesting problem that we had before. So if we wanted to add a third asynchronous thing, we could do that in here and keep chaining this as many times as we need to. And this is way easier to maintain than that callback hell garbage. So let's induce a failure. Let's modify this, and let's say it has a parameter should fail, which is initialized to false. So if r is less than that, or should fail, then we fail. So what if this first promise fails? The song data promise that starts us all off. So we've skipped all of these console.logs. All of these thens get skipped, and the first catch that we encounter gets executed with getting passed in the value that was rejected. So we see that the initial pretend song data request promise was rejected with that R value. And all of this gets skipped, okay, which is great. Let's take that back out. And what if a then? What if something bad happens within a then? Well, JavaScript promises play really nicely with existing JavaScript infrastructure. By that I mean I can throw, of course I can't return first, I can throw an error, pretend error. And this is normally handled by try catch, but a subsequent dot catch on a promise will handle this with this value. It's very nice. So let's see this. Okay, and in the error was pretend error. So here's a question. If I do a dot catch, when will this dot catch get executed? Well, if all is well, this gets executed, then this, then this. If anything goes bad, the very first catch is executed. And then this catch would only get triggered if something bad happened while you were catching this error. That should never happen. Hate it when you throw an error trying to handle an error. So let's console.log in second catch. And let's print out the error. Oops, that is an error. It's funny. Oh, everything succeeded. In second catch. All right, so something went wrong. It looks like pretend song data request was rejected, and then in second catch gets executed because we threw an oops. Without this, there's no reason to ever execute that second catch because as far as we know, it's been handled. Any errors have been handled by that initial catch. So now here's a question for you. Let's call this final then. In final then. When does this then get called? After a catch. Does it get executed when all of these succeed? Or maybe one succeeds and this one throws a catch, so is it executed after a catch? Let's find out. So we caught an error, and then the in final then was executed. So it happens after the catch, even when the catch gets executed. And everything was fine. That was executed, that was executed, that was executed. But this was also executed. Okay? And that is because if everything is fine, this catch never gets ran. So what comes after a then? Well, another then. And the value is that returned by the previous then. This one didn't return anything. What if I return 3, because this is the third then? Then we will see that the final then will get that value. But what if you return, oops, here, instead of throwing an error, what if I return an oops? So the catch gets triggered, right? Starting here, the catch gets triggered, and the final then. So this is as if everything is handled properly and then something else happens. So as long as the catch doesn't throw another error, this then will always get executed, whether or not this was the last thing or this was the last thing, and it will receive the value from the previous catch or the previous then. Just whatever was last executed, a then after a catch receives. There's a couple of other useful promise functions we should look at. So let's just ignore all of that for now. And let's say let p1 equal make promise. Its name is going to be 1. And let's make a few of these. Five and 5, 4, 3, 2. So you have at your disposal the static method all, which lives on promise, and it takes an array of promises and returns a promise. So what do you think the function passed into then receives? So after all, that's funny, and then v. Okay, so if all 5 promises succeed, that's what .all gives us. If all 5 of these succeed or resolve, then this gets executed, the first then. And the value you get is an array of each resolved value. So this is the resolved value from 1. The second index is the resolved value from 2, 3, 4, and 5. So if we run this enough times, one of these is going to fail, and we should get an error because we don't have a catch. So if we add a dot catch of e in catch, and let's just say what e is. So dot all passes all resolved values to a then, but a dot catch returns to you the very first failure that happens. So in this example, promise number 2 rejected first. Maybe other ones rejected, maybe other ones resolved, but the very first one that rejects triggers the catch, and the then is never executed. Okay. We also have at our disposal, where are my fingers? Promise dot, it's not any. I always think it's any. You have promise dot race, which I think is a funny name, which once again takes some promises. I'll fix that. And what do you think this one does? And then value. Well, it erases them. The very first promise to finish is the one that triggers the then, and that's the value that we get. So in then 2 finished first. Okay, this time 5 finished first. So we rejected. So the rejected value, let's see what that is. In catch value. Oh, I messed up again. What did I do? In catch, it's dot. There we go. So if we race, we get, if something resolves before something rejects, we get the then, right? Because we're racing. We don't care what the rest of them do. But if something rejects before anything else, then we do the catch. I think. We can actually test this. Let's test this and say console.log name rejecting, just to give us a little info. Okay, yeah, so it's the very first one. It's not all of them. It's the very first one to reject. If that happens before a successful finish, then the catch gets executed. So I'm going to make promise 1 fail. And let's see what that does. So even though promise 1 rejected, we're racing, right? So it just so happened that 1's delay was greater than this one, where promise number 3 resolved. So even though 1 rejected, we're racing. And 3 was able to resolve before 1 rejected. Twice in a row. So 4 was the very first one to do anything, and rejected, and then also 1 rejected. So 5 resolved first before anybody else, even though 1 rejected at a later time. Okay, so hopefully this has been a nice introduction to JavaScript promises. You won't fully understand them until you start using them on your own, but hopefully this gives you enough to get started.